Good day, colleagues. My name is Thabo Putsane from Linyora Tuto. I'm a digital systems educator. I'm here today to give you the guidelines about the 2020 examination preparations. 2020 Digital System Examination Preparation Guide. As a digital system educators, we are advised to always emphasize to learners to read instructions before proceeding to answer question paper, as that is the cause that most of our learners are not getting good marks in their examination. Learners must thoroughly read the question before they give answers. Learners are advised to utilize the question banks that they were provided with by the Department of Education and other old relevant question papers in order to familiarize themselves with the standard of questions that are in there and how they were answered. Cover page of the question paper inform us about the total marks of the paper, time to complete that paper, and the number of pages and attachment the paper consists with. I'll show you the question paper front cover page. It's like this. It's showing you the marks for the paper, and then this 3 hours is the duration for the paper. And then on the bottom, here they state the question paper consists of 15 pages, 1 formula sheet, and 4 answer sheet, meaning our learners must check if this information correlate with, they must check the question paper if it correlates with this information on the front, on the cover page. The first page of the question paper is a list of instructions that learners should adhere to when answering the question paper, and it is also outlining what the paper entails. I'll also show you the paper first page. Let me show you. This is instruction and information. This question paper, they tells you here the paper consists of 5 questions, and then learners must answer all the questions, and then answer the following questions on the attached answer sheet. They must also check if there are this attachment in their question paper. And then they must write your center number and examination number on every answer sheet and hand them in with your answer book, whether you have used them or not. And then sketches and diagram must be large, neat, and fully labeled. Most of our learners, they just draw the sketches, but they don't show what the sketches are all about. So they must all label them. They must label them. And then they must show all calculation and round off answers correctly to 2 decimal places. They must number answers correctly according to the numbering system used in the question paper. They must not create their own numbers. Even if the paper numbers were incorrectly written there, they must follow those numbers. And then they must use a non-programmable calculators. Calculations must include the formulae and manipulations where needed. Correct replacement of values, correct answer and relevant units where applicable, and then a formula sheet is attached at the end of this question paper. They must also check if it is there or not. Let me show you. It must be there at the end of the question paper. Here it is, meaning they must check if this formula sheet is there at the end of the paper. instructions. And then they must write neat and legibly. Let me continue with the first page of the question paper is a list of instructions that learners should adhere to when answering the question paper. And it is also outlining what the paper entails. And then our 2020 question paper, is structured like 2018 and 2019 question papers with 5 topics that are covered in grade 12. And then according to Electrical Technology CAP's document, the question paper for digital system should be allocated marks as shown in the table below. And then this is our table. For occupational health and safety, it must be 4%, and then for 8 marks. And then switching circuit must weigh 29%, semiconductors 9%, and then digital and sequential devices 29%, microcontrollers 29%. And then for 29% is 58 marks, and then for 9% is going to be 18 marks. And then the following graph, there is a graph that I will show you. This graph here is based on a data of a random sample of learners. While this graph might not accurately reflect national averages, it is useful to assess the relative decrease of challenge of each question as experienced by learners. And then average marks per question expressed as percentages. And then here in this graph, they show how learners were performed in 2018 and 2019 per question. Question 1 about safety. In 2018, learners managed to perform at 44%, and then in 2019, the percentage was increased. And then in 2018, question 2 was at 18%, and then 2019, 33%. And then question 3 was at 23% in 2018, but last year was at 31%. And then question 4 in 2018 was at 19%, but last year this question was answered at 33%. And then question 5 in 2018 was at 26%, but last year was at 23%. And then the average performance in question 2 to question 5 was very poor. Question 5 covered microcontrollers and was the worst answered question, followed by question 3, which covered semiconductor devices. Candidates seem to have lacked basic knowledge of the content and therefore could not answer the questions. And then the topics listed above, those 5 topics, were poorly and fairly answered, and as a result, educators were urged to follow the guidelines below to help our learners as they prepare for 2020 digital systems examinations. And here is our examination guidelines. Common errors that were detected last year. In question 1.1, candidates used the general explanation instead of answering the specific requirements of the question. Let's see what was the question there. Describe how teamwork improves work ethics. And then let's see in the memo what was expected. An employee with a sense of teamwork helps a team to meet its goals. Teamwork helps a team deliver quality work. Teamwork can win respect of your co-workers. Working together as a team can improve discipline in the workshop. And then teamwork will lead to improved productivity. And then point number 2, most candidates could not interpret the words protect and provide in question 1.2. And then in question 1.3, candidates responded incorrectly according to the school environment rather than referring to the industrial environment OHS context. And then the definition of the term workplace in question 1.2.2 often lacked mention of the phrase during his time of the employment. Let me check that one. Define the term workplace, and then in the memo, what was expected. Workplace can be defined as any premises or place where a person performs work. But majority of our learners didn't put this part here during the time of his employment, meaning our learners managed only to get a 1 mark for that one. Then let's go to our suggestion for our learners and us as educators to our learners. As educators, we should make learners aware that OHS also have high order questions that are not presented as in their textbooks. And those questions need a learner's insight, skill, and knowledge when they are answered. Such questions have more marks, and that is where most marks were lost because learners will be writing a point instead of elaborating to get full marks. And then, important note, our learners must also check for mark allocation when they give answers. And then, different approaches may be used to make OHS chapter more interesting. For example, the practical work is the best way to explain, to exercise safety, and to assess learners. So if possible, excursion is encouraged by visiting well-established companies such as ESCOM, Transnet, where safety is observed at all times, and the instructor there will emphasize the topics within the scope of the syllabus. And then use of video during class addressing OHS. It is important in the workplace, and then it will help if you use videos to show learners how OHS is practiced in the workplace. Learners are also urged to apply skills and knowledge from grade 10 to grade 12 in order for them to answer this question, OHS. Important note, learners should state the act the way it is stipulated in the OHS Act. They should not use their own words. Please, they must state it as it is. And then let's go to question 2. Question 2 is about switching circuit. And then most errors were at this question. In question 2.2.2, most candidates could not analyze the circuit and describe what will occur if threshold pin 6 was purposely held low. Let's see that circuit. Let's see that circuit. Or is this one here? Explain why threshold pin 6 is connected directly to ground. So majority of our learners didn't know why it was connected there. They didn't know why it was connected there. So we must help our learners to understand these circuits, educators. And then the circuit diagram in question 2.3.2 was partly drawn and not fully labeled. And then in question 2.4.1, most candidates could not identify the op-amp circuit correctly and could not explain how the reference voltage could be made negative. In question 2.5.1, candidates had difficulty in explaining how the gain of the inverting summing amplifier can be determined. And then another difficulties our learners encountered was in the calculation of gain in question 2.5.4, candidates left out the prefixes of the unit in the substitution stage. And then the calculation of this question was done well, and the gain was given in units when this was not required. In the calculation of question 2.5.2, most learners could not substitute voltage 1, voltage 2, and voltage 3 correctly. They omitted the milli. And then in question 2.5, candidates could not explain the advantage of using variable resistor instead of a fixed one. So this is where our learners encountered difficulties last year when they were writing their paper. There was an improvement in learners' responses to questions requiring drawings of output waveforms. However, question 2.6.2 and question 2.7.3 was poorly answered. Candidates' responses show that they have insufficient knowledge on this concept. And then in question 2.5.6, the candidates had a little understanding of circuit dynamics. When values of components were changed, they lacked the comprehension to explain this specifically. Most candidates named the operating point as positive voltage and negative voltage, current in and V out in question 2.7.2. And then here is our suggestion for 2020 in order for our learners to give us good results. Educators must make sure learners understood semiconductor devices topic with emphasis in silicon components such as 741 op-amp and 555 timer working principle before they can master this chapter, switching circuit. They must know the chips, pins, functions, and how to supply them, as well as their internal circuitry. And then again, educators should emphasize the difference between three multivibrators, which is astable, bistable, and monostable, and show to learners the mentioned circuit difference when both 555 timer and 741 op-amp chips are used. And then when educators explain the operation of the circuits, they must at least explain to learners thoroughly why each component is deployed in the circuit. For example, for bistable using 555 timer, at least they must explain the purpose of those resistors there, switches, capacitors, and LEDs. And then educators must put more emphasis in application circuits, like when monostable is applied for debouncy. And then including applications of circuits such as Schmitt trigger, comparators, summing amplifiers. And then for differentiator and integrator, they must also explain to learners when the circuit was created only with R resistor and capacitor, and when 741 op-amp was deployed. Educators must explain to learners how waveforms entering a certain circuit manage to change the shape at the output. So they must encourage learners to practice on how to throw circuits and their waveforms with understanding, not just throwing them, but they must understand how those waves were developed. This chapter is more into theory, but some circuits require some calculation background for designing purposes, so that learners can be able to design circuit with their desired output waveforms intervals. Therefore, as educators, we must also put more emphasis in calculations. Educators should remind learners of the following: to write the correct unit for quantities to be calculated. If they were asked to calculate resistance, the unit there must be ohm, must be this ohm. And then to use correct formula quantities to be calculated. If they were asked to calculate frequency, this is the formula that we are expecting. And then for this total time, this is the formula that we are expecting. And then to manipulate the formula correctly, making a quantity the subject of the formula. And then again, we must remind learners of the following: to apply the correct prefixes in the substitution. Like here, if there was a 16 microfarad there, they must also write 16 multiplied by 10 to the power of minus 6 for micro. And then to make use of a formula sheet, as they sometimes write the wrong formula. There are formulas in their formula sheet, but instead they will decide to write their own formulas, and then at the end getting incorrect answers. And then to practice the use of their calculators to find correct answers, especially with calculation consisting of logarithms. With all these points indicated above, marks are being lost. Marks are being lost. As educators, we must encourage learners to use calculators when they are doing corrections in our classes. And then textbooks also offer enough exercises on this topic. We can use our textbooks to exercise so that our learners familiarize themselves of using their calculators. And then learners need more exposure to the simulation that can be used to enhance learning and conceptual understanding of the curriculum. So as educators, please, we must do a lot of simulation so that we make our learners to understand this theory. And then question 3. Question 3 is about semiconductors. This question, as last year, also experiences some difficulties because in question 3.1.1, candidates failed to identify pin 1 and were not able to provide a clear description. Let's see that circuit. They were unable to identify. State, how will you identify pin 1 of the IC in figure 3.1? So majority of our learners had a difficulty to answer this question. In question 3.1.2, the stages of internal circuit of op-amp were not known by many candidates. The reasons for negative feedback for the linear operation of the op-amp was not understood by most candidates. And then candidates only wrote positive 15 and not positive 15 and negative 15. They didn't write it as a range. They only wrote this 15 for question 3.2.3. And then educators, as educators, we should highlight the following mistakes done by learners. They draw the sketches without labeling them, the sketch should indicate the correct labels. They must label their sketches. And then waveforms must show the minimum and maximum of the waves, and learners must be able to draw waveforms on the same set of axes. On the calculations, learners should write the correct formula and correct units. So no unit, we are not awarding that learner a mark. So no unit, no mark. Learners should also know the importance of negative feedback and positive feedback in op-amp circuits. And then definitions also, can also be taken from the formulae in case the learner has forgotten the definition. For example, gain for non-inverting is 1 plus RF over Rin. Therefore, the learner can say the gain is the quotient of RF and Rin, the quotient of RF and Rin plus 1. Then that learner will be awarded full marks. Learners must understand the golden rules, internal pin layout, and characteristics of 741 op-amp, as well as the importance of negative feedback and voltage follower circuit, as well as the operating boundaries of the chip of the 741 op-amp. They must know the operating boundaries. Learners must understand the internal pin layout of 555 timer and its pins function, as well again as the operating boundaries of the chip. Learners should also be reminded that they must learn how to draw the labeled circuit as well as the chip's internal connections. Formulae are always given at the formula sheet, and they are always in orderly manner, and this should also be emphasized. Please, educators, let us emphasize this to our learners so that they can do well. And then here is our suggestion for better result this year. As educators, we should place additional focus on the following issues when revising this section of content with learners. Analysis of different circuit. We must analyze a lot of circuit with our learners, and then reading information from the data sheet, and then explanation, drawing and construction of prescribed components, explanation of circuits and their operation, exposure to different components, and then use of data sheet is very important, and then we must expose them to a lot of simulation. So exposure to simulation is very, very important. And then now we are in question 4, which is digital and sequential devices. Common errors and misconception. Candidates could not draw the circuit diagrams required in question 4.2.1. And then most candidates did not provide the appropriate output logic levels in the truth table in question 4.2.2, question 4.3.3, question 4.2.2, question 4.4.2, and question 4.5.2. In question 4.3.2, the candidates could not fully explain the function of the transistor drivers. And then again, in question 4.5.2, the truth table was incorrectly completed, and most candidates used an example from the prescribed textbook, which was incorrect. Candidates gave types of counters instead of application of counters in question 4.6. And then in question 4.7, some candidates were not able to draw circuits logic diagrams for the decoder and RS flip-flop. This information is for 2019 question paper, and I hope if you can have that question paper and go through this, you'll understand that the learners did not do well in those questions, and then please educators help our learners so that they can do well in those questions. Please go through that question paper and check those points here that are, so that you can help your learners to do well in their examination. And then the register in question 4.8.1 was not correctly identified, and candidates did not describe how data was introduced into and shifted out of the registers. The uses of registers were also not known. Please let us help our learners to understand these topics. Many candidates did not know how to draw the half adder using gates, and many drawings were not labeled. So many drawings were not labeled. The drawings given were untidy and did not use the EGD approach. So most of their drawings were just drawn by hand. The operation of the four-stage asynchronous binary to BCD counter was not answered by most candidates. And then more practical and written work should be undertaken on analog to digital converters and digital to analog converters. And here is our suggestion for our learners to do better this year. So as educators, we should emphasize the following aspects. So under this topic, we have the following subtopics: displays, encoders and decoders, combinational circuits, memory element, counters and registers. And then about displays, learners must know the difference between LCD and LED 7-segment displays. And then again, they must know the types of LED 7 segments and be able to explain and to illustrate the difference between the sinking and sourcing using simple diagrams. So they must know how to connect those LEDs. They must know how to connect those 7 segments. And then they must know how to explain, to give explanation on how LCD display operate and where that operation relies on. And then to explain the challenge that was encountered with an LCD. And then again, they must explain how scientists manage to solve that challenge. Learners must be able to explain the LCD pixels. And then they must know how they are controlled for switching on and off on the screen. They must know about the LCD and LED 7 segment. And then about encoders and decoders, learners must be able to distinguish between encoders and decoders and be able to draw the circuits related to encoders and decoders. And then learners must understand the operation of encoders and decoders circuit. And then about combinational circuit, learners must understand the combinational circuit including half adder, because half adder is a combination of exclusive OR, and gate. So those are combinational circuits. Full adder, parallel adder circuits, and how data is transferred using the mentioned circuit. So they must do the practice connection of this circuit so that they can see how information is transferred, how data is transferred there. And then learners must know the gates and understand their truth tables. They must know why those truth tables are appearing the way they are. They must not just memorize them, but they must know why they are in that form. And then about memory elements, as educators, we must emphasize on the RS flip-flop, both active high and low. And then again, gated latch, JK flip-flop, D flip-flop, and touch on their truth tables by explaining how those truth tables were achieved. Please make those learners to understand those truth tables so that they can do better in their examinations. And then about counters. Learners must learn different types of counters and their timing diagrams. They must also know how to control the circuit to count to their desired count and be able to explain the operation of those counters. So please help them to understand the operation of those counters. Don't allow them to memorize them, but help them to understand. They must learn about the application of counters, such as frequency divider, and then again, decade counters. Learners must also know how to throw different types of counters. They must know how to throw those counters, because most of the times those throw-ins have a lot of marks, so they can get something from there. Learners must also know how to throw different types of counters. For example, up-down counter, self-stopping counter, and some other counters that are there in our textbooks. Note, the drawings are normally allocated a lot of marks. And then about the registers, educators must elaborate to learners about different types of registers and their purposes. And then learners must learn how to throw the circuits and be able to throw the truth tables and timing diagrams when they are given the circuits. They must also learn how circuits operate. So we encourage that more simulation should be done on all circuits where it is possible. And then adders should also be done practically. Adders must also be done practically. And then our last question is about microcontrollers. The definition of microcontrollers was vague and incomplete. And then many candidates, in our previous question paper, the definition of microcontrollers was vague and then incomplete. Many candidates did not describe the function of microcontrollers, analog to digital converter, and CIR adequately. And then in question 5.4.1, the method for sending data was not known by most candidates. And then the question on the integrated circuit bus was poorly answered, and the function of the pull-up resistors was not known. So Candidates did not know the RS-232 communication protocol, operating voltages, and its application. Please don't just allow your learners to memorize. Make them to understand those circuits so that they can do better in their examination. Please, please. In the design of the flow diagram section, many candidates confused the symbols and did not label them. Many drew the arrows in the wrong direction or left them out. So candidates did not do well in that question there. It was the last question, this one. And then here is our suggestion for better result this year. As educators, we should emphasize the main functions of microcontrollers and their applications. Please, we must emphasize the functions of microcontrollers and their applications. And then more emphasis on the uses of microcontrollers in the household systems and in industry. And then again, as educators, we should explain the internal construction of the microcontroller in the form of block diagram and in theory. And then again, learners must learn to explain microcontroller and its pin layout to connect with peripherals. And then learners must be able to differentiate between microcontroller and the microprocessor. They must know the difference. As educators, we must emphasize to learners to know the abbreviations. And then, for example, for CPU, for RAM, ROM, and the main role of the memory. And then they must know inputs and output ports, timers, analog to digital converters, including registers. Learners must learn the communication protocols within the microcontroller, as well as their communication peripherals. SCI, SPI, I2C, RS-232, RS-485 cables, and their associated voltages ranges for transmission. And then again, communication protocols like simplex, duplex, and half duplex should also be strongly emphasized. Learners must know the definition associated with the software of microcontrollers. And then those definition, they must know how to define algorithm, program, they must know a flowchart, and then they must know what are we talking about when we talk about looping, debugging, and then the basic instruction set. They must know all those definitions. They must know how to define all these terms. And then learners must know data flow symbols used for flowcharts and for programming. Learners must learn how to throw the microcontroller internal circuits and give the operation. And then again, learners must also know how to draw a flowchart indicating all the key areas as requested on the given statement. And then the following areas should be thoroughly taught with experiments where relevant. peripherals and protocols, comparisons of buses, pickaxe diagrams and symbol commands, as well as timers and registers. And then, good luck, class of 2020. And then, thank you for watching and listening.